Hello, Year 9, and welcome to today's lesson on temperature and how that affects the rate of reactions. So, today it's Wednesday. Hopefully, you're doing this lesson on Wednesday. We're going to be looking at how temperature is affecting the rate of reaction. To start with, though, I'd like you to have a go, please, at answering these questions just to see what you remember from the previous two lessons on Monday and Tuesday. So, what factors affect the rate of a reaction? What is the theory known as behind the rate of reactions? How can you increase the surface area of a chemical? What is a catalyst? And do large objects have a large surface area compared to their volume? So what is the ratio on that? So pause the video now and have a go at answering those questions. Okay, hopefully you managed to answer those questions for me. So these are the answers that I have down. So what factors affect the rate of reaction? We've got surface area, temperature, concentration or pressure, and catalysts. What is the theory known as behind the rate of reactions? It is the collision theory, the idea that particles actually physically need to collide in order for there to be a reaction. How can you increase the surface area of a chemical? Well, to increase the surface area of the solid reactant, you can either grind it into a powder or you can cut it into smaller pieces. What's a catalyst? So catalyst is a chemical that provides a lower energy pathway for a reaction to occur without being used up itself. So it's providing a lower energy pathway. And then do large objects have a large surface area compared to the volume? No. Basically, the smaller an object is, the larger the surface area to volume ratio will be. The larger an object, the smaller the surface area compared to its volume. So hopefully you got those right. So two key questions we need to kind of reflect on before we jump in any further to this lesson is what happens when you actually heat particles up and what needs to happen for a chemical reaction to occur. So again, this is another thing where I want you to pause the video. I've given you some keywords there in order to help you write down answers to these two questions. So pause the video and have a go answering these two questions. So hopefully you managed to tell me what happens when you heat particles up. Well, obviously when you heat particles up or when you heat anything up, the particles inside it start to move faster. If it's a solid, they start to vibrate faster until they change state. And then when they're a liquid, they'll then start to slide over each other faster. And then eventually, until the point at which they change state again and turn into a gas. And then in a gas, once they're a gas, they will then bounce around and move faster. So when you heat particles up, they move faster and they have more energy. And then what needs to happen for a chemical reaction to occur? You need to have a physical collision between the particles. And that collision needs to happen with enough energy so that it is a successful collision and a chemical reaction will occur. Okay, because currently I've got a piece of paper in front of me, but it is not currently bursting in flames every time an oxygen atom hits it, because those oxygen atoms are not hitting my piece of paper with enough energy that a chemical reaction is occurring. If I give those oxygen atoms enough energy, so that they've got an activation energy, then chemical reactions will start to occur because there'll be successful collisions between my piece of paper and the oxygen atoms in the air in order for burning to occur. So, what are these three things? An independent variable, a dependent variable, a control variable, and a valid investigation. So again, pause the video, have a look back through your notes, but we've been doing this since year 7. So I'll be very concerned if you guys still don't know what an independent variable is a dependent variable is and a control variable it is, and also what the word valid means. So have a go, please. What do these three words mean? So an independent variable is the thing that we are deliberately changing. So independent variable is the thing we are deliberately changing in an experiment. The dependent variable is the thing we are measuring. Okay, so it's the result that we are measuring. And the control variable is all the different types of variables that we are keeping the same. So if you're doing an experiment on temperature or speed at which different types of drinks cool down in a room, one control variable might be that it needs to be the same temperature of room. Another control variable might be it needs to be the same cup, because if you use a thinner cup, it will cool down faster than a thicker or better insulating cup. So control variables are just variables that we have to keep the same. And then valid, the word valid, a valid experiment means that the experiment we do gives us results that actually answer the question we want to know. Okay, so if you have a valid experiment, then your experimental method will actually answer the question that you want to know. So those are my independent, my dependent control variable, and also whether an experiment is valid. So this is the experiment we usually do in a class setting, and we'll show you a video of it at the end of the lesson. So if you stay on, at the end of the lesson, there'll be a video of Miss Callis and myself doing this experiment. But for the rest of the video, I'm just going to use a set of results that I've gotten from an old experiment. So setting the scene, when an ingestion tablet containing citric acid and sodium hydrocarbonate is added to water, carbon dioxide is given off. So fizzy tablets, you put in water, they will fizz up and carbon dioxide will be given off. Okay, the time taken for a certain amount of gas to form can be used as a measure of the rate of reaction. By carrying out the reaction at different temperatures between about 20 degrees Celsius and 60 degrees Celsius, we can see how the rate of reaction changes with temperature. So our independent variable is going to be the temperature. Our dependent variable is going to be the rate of reaction. Our control variables are on the slide. So if we look here, we can kind of see we're putting in 30 centimeters of distilled water, so that's one control variable. We're going to use the same indigestion tablets, so they have the same surface area and the same mass. Okay, we're not crushing one and not crushing the other. That's a different experiment. We're looking at the temperature of the water. So independent variable is the temperature of water. Dependent variable is the time taken to make 25 centimeters cubed of carbon dioxide. So that is the dependent variable. It's the time taken to make 25 cubic centimeters of carbon dioxide. Okay, our control variable will be the size of the conical flask. It will be the amount of water. Be when we start the experiment. Can you think of any other control variables? If you can think of any other control variables, I'll be more than happy for you to email me and let me know if you think of any other control variables. So you're putting 30 centimeters of distilled water into the conical flask, measure the temperature. So it should be 20, 30, 40, 50, or 60 degrees, hopefully, which is what my results are in the next slide. We then add the indigestion tablet and replace the stopper on the conical flask, start the stopwatch, and then when the glass syringe, which is what's catching the gas, reaches 25 cubic centimeters, I will stop the stopwatch and I will record my results in a table. I'll then repeat that experiment for the different temperatures in my table. Okay, so I've used in my table 20, 30, 40, 50, 60 degrees Celsius, but you can use any other temperatures you would like. It doesn't matter, as long as they are exact temperatures when you put the tablet in. Okay, so you're keeping a dependent variable. You then, at the end of that, you'd plot a graph of time against temperature, and then you would calculate the mean rate of reaction at each temperature and record the values in the results table. So that's what your results table would look like. I've actually got an extra column because I've got 60 degrees in that. And then to work out the rate of reaction, it's the amount of product made, hint 25 centimeters cubed in all of them, divided by time taken. So what I'd like you to work out for me is the rate of reaction. So the amount of product made is going to be 25 centimeters cubed for every experiment. And then you're going to divide that by the time taken. And you should get a mean rate of reaction in centimeters cubed per second. So how many centimeters of gas, how many cubic centimeters of gas is produced every second? So divide 25 by the time taken, and you should get a mean rate of reaction. So can you copy down and complete this table of results for me, please? So pause the video, copy down the table and complete the table with the mean rate of reaction in centimeters cubed. You'll also need the time taken and the temperature in degrees Celsius because you're going to use that information in your conclusion next slide. So record those two tables down, temperature in degrees Celsius, time taken in seconds, and then calculate the mean rate of reaction in centimeters cubed per second. Okay, hopefully you've managed to do that. So next up, unfortunately, it's a bunch of questions that I would like you to answer for me. Yay! So in this experiment, which is the independent variable and which is the dependent variable, mark each there, nice and easy. What factors are kept constant to ensure a fair test? State what happens to the time taken to produce 25 cubic centimeters of carbon dioxide as the temperature was increased. What happens to the rate of reaction as the temperature is increased? And explain this in terms of collision theory. So why, hint, the rate of reaction gets faster, but why does the rate of reaction get faster? Think back to that third slide of this lesson where I asked you what is the collision theory and what happens when particles heat up, and use that to explain your answers on this slide. So pause the video and answer these questions for me now. So if you were stuck on the last one, the first one's really easy. The answers are earlier on in the slides, so have a look back if you're stuck on any of those. But for the conclusion, it is here. So reactions happen more quickly as the temperature increases. Increasing the temperature increases the rate of reaction because particles collide more frequently and more energetically. More of the collisions occurring in a given time results in a faster reaction because a higher proportion of particles have energy greater than the activation energy. So you've got more particles colliding and more successful collisions because they have enough energy that they are a successful collision.